Hello everyone. In this lesson we're going to learn about lists in Python. Now lists are a basic sequential data type that store values in an ordered array. Now lists are mutable objects, which means they can be altered after they're created in memory. For example, you can add new objects to a list and remove objects from a list without actually having to create a new list in memory. Lists are heterogeneous objects, which means they can hold values of different types. So for instance, you could have integers, strings, floats, and things of different types all within the same list. So in this code cell below, we'll show how to construct a list. To make a list, you just put a sequence of different objects separated by commas within square brackets. So here we're creating a new variable called myList. We're assigning it the value of this list. So open square bracket, lesson is the first thing we're putting in the list, comma, the integer 5, comma, another string is fun, question mark, comma, and then a Boolean value true, and then we close. So here we are creating a list with 4 objects in it, and then we're just going to print it to the console to see that we've made it successfully and see what's in it there. Alternatively, you can also construct a list using the list function. So here we're going to assign a new list called secondList, the result of this function call. We're going to call the list function on this string life is study. Now, this doesn't actually just make a list of length 1 with this string. The list function is going to go through and take every single letter in this string and make it a different entry into the list. So let's just run this and see what the result is. You can create lists that don't actually have any entries in them. That is called the empty list. So here we're assigning a new list called empty list, the value of just brackets with nothing in them. That is an empty list. So we'll print it. Now you can add new objects to an existing list using the .append notation with the name of the list before the dot. So here we're going to say empty list, which is that empty list we already assigned, then .append, I'm no longer empty. So we're adding this string to the list, and once we do that, we're going to see that when we print empty list, there's actually something in it now. You can remove a specific object from a list using the list.remove notation, and in the parentheses, you put the object you want to remove. So earlier we defined myList, which had the object 5 in it. So we're saying mylist.remove 5. So after running this, mylist will no longer have the number 5 in it. And note that remove deletes the first matching item only. So if mylist had had multiple entries of 5 in it, it would have only gotten rid of one of them. Now you can join 2 different lists together using the plus operator. So here we're going to make a combined list and assign it to myList plus empty list. Well, empty list is no longer an empty list because we put something in it. So when we do this, we should see what was in myList with what was in empty lists added to the end of it. So let's print that and see that that is the case. Alternatively, you can add a sequence to the end of an existing list using the list.extend function. So here we're going to essentially do the same thing, except we're going to do .extend empty list. The result is going to be the same as the one above. Now we're going to go over some different functions you can run on lists. You can check the length of a list using the len function. So here we're saying len numList. We're assigning a new list of numbers here that is length 5. So we're going to print the result there of checking the length. You can also check the maximum value of a list using max, the minimum value with min, the sum of all the values in a list with sum. And you can also check the mean pretty easily by just doing a calculation, taking the sum of the list divided by the length of the list. Note that the reason we can do all these numerical operations is that the list itself contains numbers. Now to check membership in a list, you can use the in keyword. So basically that's checking whether a certain value exists within the list. So here we're saying one in numList. When we run that, it will check whether num is actually an element of numList and print out a true-false value as to whether that is true or not. You can also say not in to perform the inverse operation of that to check if a list does not contain a certain object. And you can count occurrences of a given object within a list using the .count method of lists. So we're going to run this, and we see that the number 3 occurs in numList 1 time. A couple other common list methods are list.sort and list.reverse. So first we're going to do the reverse operation by saying newList.reverse. After that, we're going to do newList.sort. That is going to sort the list by the elements. In this case, they're all numbers, so it will sort the numbers in ascending order. So let's just run these and see what the results are. Now, it is worth noting that when we're running this .reverse and this .sort, these methods, they are actually taking this list and altering or mutating the list itself. If you don't want that behavior and you actually want a function that will sort it and return the sorted version of it but not alter the list directly, you can use the reversed and sorted functions instead. So with that, you would just say reversed and pass in the list as an argument, and you would say sorted and pass the list as an argument instead of doing this .reverse and .sort thing that we did here. We will next learn about list indexing and slicing. So when you have a list, you have a sequence of elements, but you would like to be able to access different elements within that list when you need them. So how to do that is through indexing. Every single item in a list has an associated index that you can use to look up whatever item is at that index. And the indexes just start from 0 and count up from there. So for instance, in this list here, another list, the 0 index position is hello. And then my is 1, bestest is 2, etc. Note that the counting starts at 0, which means even though this list is of length 5, the final index is only 4. That is a common programming construct in many languages, start at 0, but it's just good to keep that in mind, that the final index of a Python list is always going to be 1 less than the length. So to access an item within a list at a given index, you just write the name of the list, so we're going to write another list, and then in square brackets, you write the index that you want to access. So right here, we're going to access the 0th index item, so this is going to get us hello. And in this print statement, we're accessing the 2nd index item. That is this, bestest, so when we print that, that should be the results. Now you can also use a negative indexing to access items starting from the end of the list. So in this case, we can say another list -1. That's saying start at the end and count back by 1. So this is accessing the item at the very end of the list. So that should get us friend. And this one is saying -3. So count 3 back from the end of the list. So that should get us 1, 2, 3, this item. So we'll print those. And note that if you supply an index that is beyond the length of the list, you will get returned an index error. So here we're trying to access index 5. Well, the indexes only go up to 4, so that is going to throw an error if we try to do that. And if your list contains objects that are themselves indexable, you can perform multiple indexing operations to grab what you want. I'll give you an example here. So here we have a nested list. Essentially, this is a list that contains other lists. So within our first list that we're defining, the first element is actually a list itself of these numbers. The second element is also a list, and the third element is a list. If we want to access individual values from this data structure, we need to provide 2 indices. One to choose which of these 3 lists we want to look at, and then the second one to choose which item within that list we want to look at. So here we're saying nested list 0. That's saying we want to look at this nested list and choose the thing at index 0. The thing at index 0 is this list. And then we're saying within that thing that we just selected with this 0, we also want to look at the thing at the second index. Well, within this, the second index is 3. So this print statement will actually grab us this 3 within the nested list. Let's run that and see that that is the case. Now, it's also possible to get multiple items from a list using what's known as slicing. So instead of supplying a specific index value, you can supply a range of values using this notation 1:3. So you use a colon to say what the slice is going to be. So basically what this is saying was we want all the objects from index 1 to index 3, but it is not inclusive of the final index. So in other words, we're not going to actually get the item at index 3. We're getting everything from index 1 up to index 3, but not including index 3. You can also specify a step size with an additional colon. So here we're taking a new slice from another list. First we're saying start at index 0, slice up to index 6, so that's getting us everything from index 0 through 5. And this second colon here is actually saying we also want to step by every 2 indices. So normally when you don't specify a step, it's always stepping by 1, as if there were a 1 here, but you don't need to do that. You wouldn't even put that on there because the default is 1. But essentially there's a hidden step here that's 1, saying I want to get every single index. But if you change that to something else, say 2, that's saying we only want every second item that is returned by this. So instead of actually getting every single thing from index 0, 1, 2, 3, 4, 5, it's actually going to skip every other one now. So we're saying we want the things at index 0, 2, 4, etc. So this will actually get us, in this case, I think 3 items, skipping every other item in that list. Another useful slicing method is to slice everything up to a certain index or everything from a certain index till the end. To do that, you just use the slicing notation, but you don't specify a beginning or an endpoint, depending on what you want to do. So if you want to get every single object up to a certain index, you use this notation. Within the indexer, you don't specify the start, and then you say colon up to what you want to slice to. So in this case, we're saying we want everything up to index number 4, but we're not actually going to get index number 4 itself. And to slice from a given index till the end, you just kind of do the opposite. You say the index you want to start with, colon, and then you don't specify an endpoint, and that will slice everything from that index till the end. Now, it is also possible to supply a negative number as the step, and when you do that, it makes you slice starting from the end of the list toward the beginning. So we'll give an example of that. Here we're saying we want to do another slice starting at index 4, going to index 2, but the step is -1, so we're slicing from the end toward the beginning. So this is starting the slice at index 4 and actually going backwards toward index 2. As you can see, even when slicing backwards, the ending index is not actually grabbed by the slice, so we only are seeing here the things at index 4 and 3. The 2 is just specifying the endpoint, but we don't actually get the thing at index 2. Now, if you use indexing with a colon but don't specify a start or an endpoint at all, you just put a colon here in the indexer, that will slice the entire list, which essentially just makes a copy of the list. And we did mention some ways to reverse a list earlier. There's actually a quick way of reversing a list using a kind of slicing trick. What you can do is slice the entire list using the colon, but also include a step of -1. So you're saying, give me the whole list, but slice it backwards. And what that will do is essentially just reverse the list. Now you can use indexing to assign new values to a list at the given position. So for instance, if we wanted to change the item at index 3 to something different, we could do that by saying another list, the thing at index 3 equals something new. So here we're saying we're going to set it to the string new. So here we're using the del function, which will delete something. And we're saying delete from another list the thing at index 3. And that will just delete the item from index 3 completely, and the list will shrink in size after that. So we'll run that and see that new is in index position 3 after we added it, but then we deleted it and the list got shorter after that. Another way to remove something from a list is using the list method .pop. Pop will remove the final item from a list and return it. So if we run this here, next item equals another list.pop, that is going to strip off friend from the end of the list. So next item will be friend, and then another list will have one fewer item in it. So let's run that and confirm that that is the case. So notice that a list resizes itself dynamically as you delete or add items to it. Appending items to the end of a list and popping items from the end of a list is a very fast operation, but deleting or inserting items anywhere else within a list tends to be relatively slow because the computer will have to shift various things within the list around in memory to make space for that. So just note that append and pop are quite fast, but as soon as you start doing lots of insertions and deletions within the kind of body of a list, that could start to bog things down a bit. Now, to finish up this lesson on lists, we are going to talk a bit about copying lists. So as mutable objects, lists can actually be changed in place in memory without creating a completely new list. Things can be added and deleted from an existing list. But you can also create copies of lists, which actually create a whole new list in memory. And the distinctions between when lists are being altered in place or when actual completely new copies are being created is kind of one of the easier things in Python to get tripped up by. It's pretty common to be making functions and have lists be doing things you weren't expecting because perhaps you're changing a list that you thought you weren't changing because you thought you made a copy of it or things like that. So it's important to be aware about the kind of mutability of lists and some different operations for making copies of lists. So here we'll show how to do some of that below. So we're going to start by making a new list. And now we're going to use the .copy method to make a copy of the list. So here we're saying list2 is going to be list1.copy. That is making a copy of the first list in memory, and this will create two separate lists, but that have the same things in them. So when we run list1.append 4, that is adding 4 to this first list. It will not add 4 to the second list because that is a copy that is now distinct from the first list. So when we print these two, they should be different because we didn't actually add anything to the second list because it was a separate copy. So I'll run that and see that that is the case. As expected, we didn't add anything to the second list. But now I'll show an example of something that seems very similar but results in a different behavior. So here we're going to again define list1 as 1, 2, 3. Now we're going to define list2 as something different. We're going to have a string, and then list1 is also going to be in list2. Third, we're going to make list3 be a copy of list2. Then we're just going to check what is actually in lists 2 and 3 right now. We're going to append the number 4 into list 1. And then after that append, we're going to again check what's in lists 2 and 3. Let's run this and see what the result is. So before adding something to list 1, lists 2 and 3 were the same. And after adding 4 to list 1, now in list 2 and 3, we actually see the 4 there. Even though list 3 was only a copy of list 2, which contains list 1 as one of its elements, when we changed list 1, list 2 and 3 also were changed because this object here is actually list 1 itself, not a copy of list 1. The reason that happened is because the .copy function does what's known as a shallow copy of a list. It basically only does a copy of everything at the base level of the list. If there are items within the list that themselves contain objects, it doesn't copy everything within that. So the fact that we had list 1 within another list, essentially a nested list, it doesn't copy the nested aspect to it. So if we wanted to prevent this kind of behavior of something within our list not being copied, we would have to do what's called a deep copy. You can do that using the copy package within Python. So to do that, we can say import copy, that loads in the copy module. And then when we make list 3 here, instead of using list2.copy, which creates a shallow copy, we can use this copy module to use its deep copy function. So we're going to say within the copy library, use the .deep copy function and run that on list 2. So that will allow list 3 to be a deep copy of list 2 instead of a shallow copy. So that means everything nested within list 2 is also being copied. So this will create list 3 that has an actual copy of list 1 in it, not list 1 itself. So when we perform these same operations and add 4 to list 1, that is not going to add 4 to the copy of list 1 that we put inside list 3. So when we print all of this out, list 3 shouldn't have this 4 in it anymore because we did a deep copy this time. And you can see that while list 2 does have the 4 because we didn't have a deep copy for that, in list 3 the 4 is not there because this is a copy of list 1, not list 1 itself. Now you might not run into these sorts of copy issues right away when you're starting to learn Python, but just know that things like this can come up. And it's good to be aware of these sorts of issues because lists are actually perhaps the most common and ubiquitous data structure in Python. So when you're using Python, you're going to be seeing lists all the time. Now I will say that for data analysis and data science, there are actually some other sequential data structures available in Python packages that tend to be used more than lists in some cases because they allow for faster mathematical operations on many values at the same time. But despite that, you're still going to be using lists a lot, regardless of how you're using Python. In the next lesson, we're going to learn about two immutable sequence data types in Python, and those are tuples and strings. So thanks for watching, and I'll see you next time.